Great guys. So we are stepping into the unit 4 knowledge representation. We just look for the easy way to understand what is this knowledge representation. So the term is clear that we are trying to represent the knowledge that is from human to a mission. The stupid mission want to have the knowledge like how the human have. So usually the human will be thinking exactly in the way, say for an instant, uh, Peter is coming to the class tomorrow, or the Sam is going to take leave tomorrow. But the mission can't remember like this way. So we have to frame a logic behind it because the mission is going to handle a huge, humongous database where, say for the same instance, we'll be having a so many number of student record. Then for all each record, we cannot make the machine to learn in that way. So we have to create a logic so that anything can be mapped into the respective particular data. Hope you understand. Look, we might have the like king, you know, uh, Alexander. We have the king Raja Cholan. Right? We have the king Akbar. Now, individually, it cannot be represented to the mission. We need the logic. We need the logical statement that can substitute any king name over in the logical statement we are trying to make the mission to learn. Here we go. King of X. Now, this X could say it can be a Alexander, it can be a Raja Cholan, it can be Akbar. The same way, student of Y. So this Y could say Peter, Sam, Singh, and so on. So this is how we are trying to make the logical statement where the variables can have the constant or values. So not all individual data has to be fed to the machine. Instead, we'll be framing a logic. So this way, we'll be having a, the important concept as a unification. So meantime, we'll be having a preposition, logic, predicate, logic, and this is also called as FOL, that is first order logic. So these are the, right, it maybe looks like a grammatical statements, right? The same way we are making the knowledge to be represented to the mission with having all those logic so that any number of data can be easily accommodated with the logic we are trying to define for it. Right. So this preposition logic is actually in, we can say it's a concise, means it will be very generic. Say for an instance, it's raining. So means it doesn't have the location name, it doesn't have the time. It just have the information, it's rain. So this is how the logic of preposition will be built. And of course, a machine will be having this preposition logic too. At cases, right, we'll be having the preposition logical statement from the machine, right? So you guys might remember the DBMS, right, database management system, how the query is posted in order to get the results from the data bank, right? The same kind, hope you remember, right? Select star from student, right? Here star means all students from the student table. Select star from student where section is equal to R2. Now we are trying to create a, constraint the student table which have the value of section is R2. Those student name will be brought. I'm not querying right exactly select right Harshit or select respective select yes data from the R2 section. I'm trying to fetch the whole student name, those who belong to the R2 from the student table. So that's the way, right? Like the machine will be trying to connect to the database. So that's what we are trying to make the machine to understand, and we are representing all those knowledge into a machine, right? So coming back, this proposition logic will be very concise, like it's raining, and this predicate logic is very precise, where we can have the example, it's raining at Chennai at 6 p.m. today, right? So now the information is damn clear. It says the location, it says the time, right? So it was saying what's happening there. So this is predicate logic. So I hope you understand the difference between preposition and predicate, right? We'll be going for a briefer example, right, in next session, right? But because, right, we are going to step into the unification, which will be very quite easy and understandable. So I thought to start with this unification, all right? So we directly move on to the unification, and again this unification comes under the knowledge representation. So unification, it's simple, it's a process, right? Unification algorithm, right, or unification logics. Unification algorithm is a of substituting process of substituting, right, or finding a way to substitute to make two logical statement to be identical. So hope you understand, right? So it's simple. It's a process of substituting or finding a way to substitute in order to make two different logical statements to be identical. The same example what we seen above, right? So King John, this is one statement. King Jane, this is one statement, right? So now we are having certain rules that has to be followed while we go for the unification process. First, we understand unification is a process of finding the substitute in order to make the two different logical statement to behave like a one single identical statement, right? So the rules are, right, so we go with the same instance, right, this one, right? So before that we just quickly know about the rules, right? Rules. First, two different logical statement that should have same predicates. I'll let you know what is predicate, right? Right. So here in this example, King, like John or Jane, whatever, this is the predicate, right? And this is value or constant. Now, the second rule is both logical statement should have equal number of variables. That is quite important, right? So here in this example, we are having a predicate, this is King, we are having a constant or value John and Jane, but the variables, number of variables for the logical statement, here we are having one, here we are having one. So both are having a same number of variables, so we can apply the unification process over here. This is quite important. Always we have to check the number of variables in individual logical statement. Only if it's matched, then we can go for it. Third, if we are having different that is or we can say, right, if we are having two variables in two logical statement, and if both have same variables, then unification is not applicable. Unification is not applicable. It's quite important because at times we'll be having a two different logical statement, and if both are having a same variable, then the unification cannot be go, right? So remember these rules. So we should have the predicate, same predicate, we should have the same number of variable, and both the variables, if there is more than one variable and both the variables should be not the same variable, then the unification process cannot be achieved. But we can do a rearranging the variables, right? Or we can say replacing the some other variables in one logical statement and go for the unification process. We can go with the global examples, right? What I've given over here. So King of John, King of Jane. How we can write this? So we can write this as King of X. So this is one logical statement. This is one logical statement. We understood both are having a same predicate. The predicate is king. We understand the constant value for the first logical statement is John. Constant or value for the second logical statement is the Jane, right? Now we are trying to make it unified by means of substituting a variable over in the place of a constant. So now this single statement can fetch the value for both logical statement. So King of X, this X could be John, this X could be Jane. So this is the process behind it, right? We go for the global example, right? Unify, no, right? Unification going to happen for this statement. First we go with the nose of John of X, then nose John of Jane, right? We go for this first example. Unification, right? So nose John, right, comma X, John comma X, then nose John comma Jane, nose John comma Jane. Now we are going to perform a unification process. We understood the first rule. Both the logical statement have the predicate as common, nose, and both the logical statement have two variables. Here also two variables, here also two variables. Now we are going to substitute the variables in order to make the two different logical statements to be identical, right? So what we can do? So we can make this as nose John, comma, this X could be replaced by Jane. So this actually have an implied meaning. John knows Jane, and again knows John comma X, right? So we can make the statement, unification statement, like this, so that it covers both the logical statement, right? Because we are having an X, this X could be replaced by Jane or even Peter or even Sam and so on, right? So this is how the unification process will be done. So we are having a two logical statement, but we are making to one by making it identical. So we are just substituting the variable. So as we already have one variable statement in one logical statement given, so we are just making use of that, and that X is replaced by the other statement, right? This is how it's very simple. So we will be going for another one, knows John comma X, known Y comma Bill, right? So second unification, knows John comma X, knows y comma bill, y comma bill. Right. Now, first we check for the rules. We do have the common predicate. Then we do have the same number of the same number of variables in both the logical statement. So we can apply the unification process. And one more rule is not the same variable is available in both the statement, because one we are having x and another we are having an y. So what we can do, we can simply go for the direct example, right? So knows, right, John, this x could be replaced by Bill, right? The knows y could be replaced by John, right? So now what happened? John knows Bill, right? And John knows Bill, right? So in the first logical statement, the x is replaced by Bill. So x is replaced by Bill. In the second logical statement, y is replaced by John. So this is how a simple way to do the unification process, right? So this is the representation of unification, right? So right, to make it common, right, we can say this knows y comma x. So unification happens for this example, right? So now we go with the third example, that is unify knows John comma x knows y comma mother of y. So it's simple, right? So we understand both have the same predicate, both have the same number of variables, here John and x, here y and mother of y. So it's simple, we can replace in the first logical statement x with the mother of y, right? And in the second we can have y is equal to John, right? In that case, the second logical statement will be like this, right? Knows John comma mother of John, right? So John knows mother of John. Now the fourth example, the statement, two logical statement, knows John comma x, knows x comma Elizabeth, right? Here the predicate is same, good. The variables in the first statement is 2 and the second statement is 2, that's correct. But the third rule, where we cannot have the same variable, right, in the two logical statement, which actually makes the unification to be get failed. So first we have to replace the variable 2 and another variable so that the unification process can be done. So how we can make knows John comma x, then knows y comma Elizabeth, so that x could be replaced by Elizabeth, y could be replaced by John. So this is how the unification process goes when we are having a same variables in the two logical statement. So before we are making it identical, we have to replace the variable. So this is how the unification process goes on, and this is how the knowledge representation it happens with the mission to handle the pool of data. It's easy to grasp.